So before we can talk about Elasticsearch, we need to talk about REST and RESTful APIs. The reason is that Elasticsearch is built on top of a RESTful interface, and that means to communicate with Elasticsearch, you need to communicate with it through HTTP requests that adhere to a REST interface. So let's talk about what that means. So let's talk about HTTP requests at a more high level here. So whenever you request a web page from your browser, what's going on is that your web browser is sending an HTTP request to a web server somewhere requesting the contents of that web page that you want to look at. And Elasticsearch works the same way. So instead of talking to a web server, you're talking to an Elasticsearch server, but it's the same exact protocol. Now, an HTTP request contains a bunch of different stuff, more than you might think. One is the method, and that's basically the verb of the request, what you're asking the server to do. So in the case of actually getting a web page back from a web server, you'd be sending a GET request saying that I want to get information back from the server. I'm not going to change anything or any information on the server. I just want to get information back from it. You might also have a POST verb. That means that you want to either insert or replace data that's stored on the server, or PUT, which means to always create new data on the server, or you can even send a delete verb. That means to remove information from the server. Normally you wouldn't be doing that from a web browser, but from an Elasticsearch client, totally a valid thing to do. It also includes a protocol, so specifically what version of HTTP are you sending this request in? Might be HTTP/1.1, for example. You will be sending that request to a specific host, of course, so if you're requesting a web page from our website, that might be sundog-education.com, and the URL is basically what resource you are requesting from that server, what you want that server to do. So in the case, again, of a web server, that might be the path to the web page that you want on that host. There's also a request body you can send along. You don't normally see that with a web page request, but you can send extra data along in whatever structured data you want to the server within the body of that request as well. And finally, there are headers associated with each request that contain sort of metadata about the request itself. For example, information about the client itself, that would be in the user agent for a web browser, what format the body is in, that might be in the content type, stuff like that. So let's look at a concrete example, again getting back to the example of a browser wanting to display a website. This is what an HTTP request for that might contain. In that example, we're sending a GET verb to our web server, and we're requesting the resource /index.html from the server, meaning we want to get the home page. We will say that we are sending this in 1.1 HTTP protocol, and we are sending it to a specific host, and that's our website, sundog-education.com. In this example, there is no body being sent across, because all the information we need to fulfill this request has already been specified, and there'll be a whole slew of headers being sent along as well. That contains information about the browser itself, what type of information and languages it can accept back and return from the server, information about caching, cookies that might be associated with this site, things like that. So a bunch of information about you being sent around the internet whenever you request a web page. But fortunately with Elasticsearch, our use of headers is pretty minimal. So with that, let's talk about RESTful APIs now that we understand HTTP requests. So the really pragmatic, practical definition of a RESTful API is simply that you're using HTTP requests to communicate with your web service of some sort. So because we're communicating with Elasticsearch using HTTP requests and responses, that means that we're basically using a RESTful API. Now there's more to it than that, we'll get to that, but at a very simple level, that's all it means. It sounds fancy, but that's really it. So for example, if I want to get information back from my Elasticsearch cluster, like search results, for example, I'm actually conducting a search, I would send a GET verb along with that request saying I want to get this information from Elasticsearch. If I want to insert information into it, I would send a PUT request instead, and the information that I'm inserting would be within the request body. And if I want to actually remove information from my Elasticsearch index, I would send a delete request to get rid of it. Now, like I said, there's more to REST than that, so let's get into the computer science-y aspect of it. REST stands for Representational State Transfer, and it has 6 guiding constraints. And, well, to be honest, these aren't really constraints, not all of them. Some of them are a little bit fuzzy. We'll talk about that. Obviously, it needs to be a client-server architecture we're dealing with. The concept of sending requests and responses from clients to servers doesn't really make sense unless we're talking about client-server architecture, and that is what Elasticsearch offers. We have an Elasticsearch server, or maybe even a whole cluster of servers, and several clients that are interacting with that server. It must be stateless. That means that every request and response must be self-contained. You can't assume that there's any memory on the client or the server of the sequence of events that have happened there, really. So you have to make sure that all the information you need to fulfill a request is contained within the request itself, and you're not keeping track of state between different requests. Cacheability, this is more of a fuzzy one. It doesn't mean that your responses need to be cached on the client. It just means that the system allows for that. So maybe your responses include information about whether or not that information can be cached. Again, not really a requirement, but it's on this list of REST constraints. Layered system, again, not a requirement, but it just means that when you talk to, for example, sundogeducation.com, that doesn't mean you're talking to a specific individual server. That request might get routed behind the scenes to one of an entire fleet of servers, so you can't assume that your request is going to a specific physical host. And again, this is why statelessness is important, because one host might not know what's going on in the other necessarily, so they might not be talking to each other really. Another sort of fuzzy constraint is code on demand, and this just means that you have the capability of sending code across as a payload on your responses. So for example, a server might send back JavaScript code as part of its response body that could then inform the client on how to actually process that data. We're not actually going to be doing that with Elasticsearch, obviously, but REST says you can do that if you want to. And finally, it demands a uniform interface, and what that means is a pretty long topic, but at a fundamental level, it just means that your data that you're sending along is of some structured nature that is predictable, and you can deal with changes to it in a structured way. So at a high level, that's all it is. With that out of the way, why are we talking about REST at all here? Well, the reason is that we're going to do this whole course just talking about the HTTP requests and responses themselves. And by dealing with that very low level of how the RESTful API itself of Elasticsearch works, we can avoid getting mired into the details of how any specific language or system might be interacting with Elasticsearch. Pretty much any language out there, Java, JavaScript, Python, whatever you want to use, is going to have some way of sending HTTP requests. So it really doesn't matter what language you're using. What matters more in understanding how to use Elasticsearch is how to construct these requests and how to interpret the responses that are coming back from it. The mechanics of how you send that request and get the response back is trivial, right? Any language can do that. If you're a Java developer, you can go look up how to do that. So we're not going to get mired in the details of how to write a Java client for Elasticsearch. Instead, what we're going to teach you in this course is how to construct HTTP requests and parse the responses you get back from Elasticsearch in a meaningful way. And by doing that, you'll be able to transfer this knowledge to any language and any system that you want very easily. Some languages may have a dedicated client library for Elasticsearch that provides sort of a higher level wrapper over the actual HTTP requests and responses, but they'll generally be a pretty thin wrapper, so you still need to understand what's going on under the hood to use Elasticsearch successfully. A lot of people get confused on that in this course, but there's a very good reason for why we're just focusing on the actual HTTP requests and responses and not the details of how to do it from a very specific language. All of Elasticsearch's documentation is done in the same style. The books that you can find about Elasticsearch, same idea. There's a good reason for that. So the way we're going to interact with Elasticsearch in this course is just using the curl command on a command line. So again, instead of using any specific programming language or client library, we're just going to use curl, which is a Linux command for sending HTTP requests right from the command line. So we're just going to bash out curl commands to send out requests on the fly to our service and get the responses back and see what comes back from them. The structure of a curl command looks like this. Basically, it's curl-h followed by any headers you need to send. And for Elasticsearch, that will always be content type of application/JSON, meaning that whatever's in the body is going to be interpreted as JSON format. It will always be that. And in fact, we're going to show you a little bit of a hack on how to always make that header specified automatically for you on curl to save you some typing. That will be followed by the URL, which contains both the host that you're sending this request to, and in this course that will usually be the local host, 127.0.0.1, followed by any information that the server will need to actually fulfill that request. So, what index do I want to talk to? What data type? What sort of command am I asking it to do? And finally, we will pass -d and then the actual message body within quotes. That will be JSON formatted data with additional information that the service needs to actually figure out what to give back to you or what to insert into Elasticsearch. Let's look at some concrete examples to make that more real. So this first one on the top here, we're basically querying the Shakespeare index for the phrase to be or not to be. So let's take a closer look at that curl command and what's in it. Again, we're saying curl-h content type application JSON. That's sending a HTTP header that says that the data in the body is going to be in JSON format. -x get means that we're using the get method or the get verb, depending on your terminology, meaning that we just want to retrieve information back from Elasticsearch. We're not asking it to change anything. And the URL, as you can see, includes the host that we're talking to, in this case 127.0.0.1, which is the local loopback address for your local host. Elasticsearch runs on port 9200 by default, followed by the index name, which is Shakespeare, and then followed by _search, meaning that we want to process a search query as part of this request. The question mark pretty is a query line parameter. That means that we want to get the results back in a nicely formatted, human-readable format, because we're going to be looking at it on the command line. And finally, we have the request body itself, specified after a -d and between single quotes. And if you've never seen JSON before, this is what it looks like. It's just a structured data format where each level is contained within curly brackets. So it's always contained by curly brackets at the top level. And then we're saying we have a query level. And within those brackets, we're saying we have a match phrase command that matches the text entry to be or not to be. So that is how you would construct a real search query in Elasticsearch using nothing but an HTTP request. Another example here, we're going to be inserting data. So in this one, we're using a put verb, again to 127.0.0.1 on port 9200. This time we're talking to an index called movies and a data type called movie, and it's using a unique identifier for this new entry called 109487. And under movie ID 109487, we're including the following information in the message body. The genre is actually a list of genres, and in JSON that will be a comma delimited list of stuff that's enclosed in square brackets. So this particular movie is both the IMAX and sci-fi categories. Its title is Interstellar, and it came out in the year 2014. So that's what some real HTTP requests look like when you're dealing with Elasticsearch. So now that you know what to expect and how we're actually going to use Elasticsearch and communicate with it, we can talk more about how Elasticsearch works and what it's all about. We'll do that next.